Find the area of the region between y is equal to x cubed minus x squared minus 2x and y equal to 0. Now this is a little it's kind of hard to picture this, so you might want to have to draw it and see. You know, you have to obtain the curve to determine where basically where the curve lies above and below the x-axis, etc. So it's really a good idea to kind of see what it looks like already, so you see the limit, you know what I mean, because we kind of know that we're going to use integral, because typically when they ask us to find area under the curve or area between and etc., that's typically integral. But then you would need limits to basically solve that problem. Okay, so now we can try to visualize what this looks like. Okay, so we have y is equal to x cubed, so we can put x, you factor out x, see what we have. So we have x squared minus x minus 2. Okay, and we can further factor this out. So the product is supposed to be I can't remember. Is it the product is supposed to be minus 1 and then the sum? No, the product is supposed to be minus 1 and then the sum is, the product is supposed to be minus 2 and then the sum is equal to minus 1. So it could be, I'll verify that later, but you could use different methods, but that's typically easier. So let's see here, x minus 2, product minus 2 plus 1, get x squared plus x minus 2. Right, so that's correct right there. Okay, so now y is equal to 0. I'm trying to graph this, sketch it. If x equal to 0, right, y is equal to 0 if this is 0, or this is equals to 2, and this is equal to minus 1. Okay, so I can do this real quick. Okay, so I have 0 as the origin, I have minus 1, and then I have a 2 here somewhere. This is a 1 and 2. You just do it approximately, you just want to see. Okay, so the graph should look like, if I'm not mistaken, something like this. It will go through minus 1, come back to 0, and goes back to 1, right? So you have your limit here at minus 2, I mean at minus 1 and 2, and now you could clearly see that you have a limit here. So your area, the region between this graph and 0, is a subtraction of the area here and here, from minus 1 to 0 and from 0 to 2. So we can take the integral between minus 1 and 0 of that curve, which is x cubed minus x squared minus 2x. Okay, push it up a little bit. Minus, not plus, but minus, remember, is the area between that and y is equal to 0. Y equal to 0 is y equal to 0. You know what I mean? You have to picture that mentally in your mind. So you subtract the area under this curve minus that to get the well, not intersection, but the the region lying in between them. Minus from 0 to 2. Same thing. Now from here is just your basic rules of integral, which I've made a videos of, I think, in a couple months ago, so you could review that as well. Okay. Or you can also go to your handbook. I didn't do that because this is kind of basic, so you don't want to waste your time with the basic stuff either. I just wanted to show you how it's a good idea to sketch it out and find the limits. Okay, so now from here we can just solve the problem using integral, basic rule. Okay, so this would be x4 over 4 minus x cubed over 3 minus x squared. Between minus 1 and 0, same thing here, and then you find your answer. Oh, sorry, it's not integral. Okay, so I have same thing, x fourth between 0 and 2, and you should get a scalar, you should get a number, and that's it. If you do this, so you got a 0 here, 0 0, and then minus 1. I don't know if I want to do this, but yeah, you just plug in your stuff in your calculator and be really careful with your signs, and that's it. You should get an answer here. I didn't do it all, but yeah, so this is basically the method. Okay, all right, thank you, and see you in the next video.